for low productivity and abandoned oil wells. Our new thermal pressure technology provides complete hydrocarbon extraction from abandoned and low-producing depleted wells. The well's productivity and life is dramatically increased due to hot gases created by a reaction of our high-energy propellants combined with an environmentally safe oxidizing compound. The energy of the mixture exceeds many times the energy of any known chemical explosives. High-temperature gases resulting from the chemical reaction open the well's perforated zone, creating pyramids of pores and cracks in the bedrock around the well. The well's perforated zone, micropores, cracks, and crevices in the surrounding well bedrock are cleared from sediments of paraffins, asphaltins, tars, cemented drilling fluids, which increases the porosity and permeability of the bedrock. This drastically increases the recoverability of the oil and the well's productivity and life. We use our enhanced oil recovery technology for wells with productive hydrocarbon zones and layers located 1,500 feet to 20,000 feet deep and with carbonate formations of up to 32%. The thickness of hydrocarbon productive zones and layers can be from 5 feet to 600 feet. A well can have multi-layer productive zones at different vertical horizons. The close proximity of lakes, rivers, and underground layers of water are not desirable. In order to undergo successful treatment, the well's technical conditions have to withstand the circulation of high pressure, high temperature, treatment mixture, and its gases inside and outside of the well's tubing. The tubing should be liquid and gas-proof. In order to apply for a well's treatment using our technology, the client has to submit a checklist of required information: the geophysical character and specification of oil well and field, the well structure and technical specification, the depth of the well and hydrocarbon layers, the depth of productive hydrocarbon layers and reservoirs, perforation intervals and filters, number of diameter of perforation holes for 3 feet, the well's productivity history from the start and depletion curve, the chemical spectrum of hydrocarbons, bedrock, and waters, porosity and permeability of bedrock around the well, present static and working pressure, along with temperature characteristics, daily liquid outputs, location and specification of underground waters within the proximity of the well. The pump recovery tubing is moved down the well to a productive zone, and mixture number 1 with specific density 1.3 gram per cubic centimeter is pumped into the well. Then the tubing is lifted 60 feet above the top of the productive zone, and mixture number 2 with specific density 1.6 gram per cubic centimeter is pumped into the well. Leave the well for 12 to 14 hours to let the hot reaction gases filter into the well's hydrocarbons and surrounding bedrock and unclog the perforation zone, pores, and cracks of the bedrock. Then mixture number 3 is pumped into the well up to the wellhead to neutralize the acids of the chemical reaction. The exothermic reaction of high energy propellant with an oxidizer produces pulsing waves of chemically active hot gases. Up to 270 degrees Celsius and 70 atmospheric pressures, atomic hydrogen recombines into carbon and nitrogen oxides and steamed acids. These products and hydrogen filter into the bedrock around the well through unclogged perforated zones, which increases up to 7 times the speed of filtration. The major thermodynamic potential of the mixtures penetrates into the bedrock around the well, but not in the well tubing, creating micropores and cracks in the bedrock. The hydrogen filtered into the bedrock creates a partial pyrolysis of long-chain hydrocarbons, paraffins, asphaltins, resins, and more. At the same time, it disrupts the bonding of hydrocarbon molecules with the bedrock surfaces inside of the bedrock pores, crevices, and cracks, thus releasing much more hydrocarbons to be recovered. Our technology was successfully utilized with oil wells in the Russian Federation, the Ukraine, China, the USA, and Central Asia's former Soviet republics. Up to 95% of all hydrocarbons in treated wells were recovered with many times increased productivity and life of the treated wells. The cost of the treatment of the wells using our technology is comparable with the average and middle-level maintenances of a well. It is less expensive than hydrofracturing, more environmentally safe, and more productive. Up to 95% of all hydrocarbons in treated wells can be recovered. The conventional technology leaves between 40% and 80% of unrecovered hydrocarbons inside the well. Our technology disrupts the bonding of hydrocarbon molecules with bedrock surfaces inside of bedrock pores, crevices, and cracks, and releases many more hydrocarbons. Up to 80% of the remaining hydrocarbons can be recovered. U.S. patent is pending. Our technology is certified by California EPA as environmentally safe and biodegradable. We recover up to 80% of hydrocarbons left in abandoned and low-producing wells, and we will improve the productivity and life of depleted wells in a manner that is economically effective. In total, the hydrocarbon productivity of treated wells is increased from 5 to to 30 times. Productive time of wells is increased up to 5 years for some wells. This unique technology is applied to wells up to 4 miles deep and stimulates the oil and gas deposits as far as 1,700 feet around the well's pipes to recover up to 90% of hydrocarbons left in abandoned and low-producing wells. In order to apply for the enhanced oil and gas recovery by our technology, please go to EOR checklist subpage in our website www.